Good morning everyone. Welcome to GOUTAM'S classes. Today our topic is factorization method. We shall understand today what is factorization, how it works and helps you factorize a quadratic polynomial, and at the end we shall derive quadratic formula also using factorization method. So let us start. First of all, let me tell you, when I take two numbers, suppose 2 and 3, and I multiply them, I get 6. This is called multiplication. This is multiplication, correct? And here 6 is called multiple and 2 and 3 are called factors of 6, right? 2 and 3 are called factors of 6. This is called multiplication. When you do the reverse of this, when you write the multiplication backwards, this will be called factorization. Suppose I write 6 and then I represent it as product of 2 and 3, like 2 into 3. This is called factorization. I have written 6 as a product of its factors. The factors are 2 and 3. This is called factorization. Alright. So, factorization simply means undoing multiplication. Undoing multiplication. Just opposite of multiplication. Now, I can say factorization as the process in which we express an expression or a number as a product of its factors. Alright, that's clear. Now let's talk about quadratic polynomial. A quadratic polynomial is the product of two linear polynomials. You know that. Now, if you will be able to express a quadratic polynomial as a product of its factors, who are the factors of a quadratic polynomial? Those linear polynomials which got multiplied to give you the quadratic polynomial. So, if you will be able to express a quadratic polynomial as a product of its factors, that is called factorization. So, I can explain you a little better. If I take a linear polynomial 1, multiply with another linear polynomial 2, then result will be always a quadratic polynomial. This is multiplication. Now, similar to this, if I tell you, if you write the quadratic polynomial, the product of this step, if you express quadratic polynomial as a product of linear polynomial with this linear polynomial, then this step will be called as factorization. This is factorization. Alright, so hope you are clear. We expressed here the quadratic polynomial as a product of the linear polynomial 1 and linear polynomial 2. This step will be called as factorization. Now, one question. Can we always express quadratic polynomial as product of two linear polynomials? Yes, we can always show it because a quadratic polynomial is product of two linear polynomials. That's it. Now let me explain all these things and discuss the next part through one example. Okay, I'm taking a simple example. Let 2x plus 3 be one linear polynomial. Another linear polynomial is 4x plus 5. And I'm going to find their product. As I explained in the previous part, I was multiplying two numbers or two linear polynomials. Here are those two linear polynomials as an example. I have taken 2x plus 3 and 4x plus 5 as two linear polynomials. Their product will be no doubt a quadratic polynomial. What are the steps of multiplication? In multiplication, we multiply by distributive property all the terms of one expression with all the terms of the other bracket, all the other expression. So here 2x is the first term. I'll multiply 2x with all the terms of this expression, means 4x plus 5. 2x will get multiplied with 4x as well as with 5. Similarly, plus 3 will get multiplied with 4x plus 5. These are our steps of multiplication. 2x into 4x gives you 8x square. 2x into 5 gives you 10x. 3 into 4x gives you 12x. And 3 into 5 gives you 15. Now, one more step is left. 8x square, 10x plus 12x are like terms. They will get added. 10 plus 12 gives you 22. x plus 15. This is the last step and it gives you a quadratic polynomial, you see. So by multiplying two linear polynomials, you are getting a quadratic polynomial. This is what we did, what we multiplied. This is multiplication. Now, as I said in the previous part, that factorization is undoing multiplication. So I will undo multiplication now. Undo means just write the steps of multiplication backwards. So starting from this step. So 8x square plus 22x plus 15, this is our starting point. This is the product of this particular multiplication. Now I will express this expression as product of its linear factors, because this quadratic polynomial was obtained by multiplying two linear factors. At the end I should get these two. At the end of factorization I should get this. So here I am doing factorization. I'll write the steps of multiplication in backward manner. First I wrote this, then I will write this step. So 8x square plus 10x plus 15x, sorry, plus 12x plus 15. Now the step before this step was 2x into 4x plus 5, 2x into 4x plus 5 plus 3 into 4x plus 5. Then the last step, which gives you the two linear polynomial. The factors of our quadratic polynomial 8x square plus 22x plus 15 are these two. So this is the end. We expressed here this quadratic polynomial as product of two linear factors, two linear polynomials. That's it. This is called factorization. Let me mention here. This is factorization. You expressed the quadratic polynomial as a product of its factors. That's it. Now let us try to understand what steps we did. What are the steps? In the steps, what we actually performed. I just copied the steps of multiplication backwards and I told you this is factorization. We will have to understand actually what happened in each step. Then only we will be able to do the factorization of quadratic polynomial. Okay, so we have to understand these steps. Actually what happened here. Let us observe. First, for that I am comparing this with standard form of our quadratic polynomial, ax square plus bx plus c. This is standard form of our quadratic polynomial. Now comparing this with this, you come to know that ax square is 8x square, 22x is bx and c is 15. That's right. Now see the second step. When you factorized here, what happened? 8x square is as it is, 15 is as it is, means ax square and c will be kept as they are. But what about this middle term, which is bx actually? This middle term has been written in two parts. Middle term has been, in other way I can tell you, this middle term has been split or has been divided into two parts, 10x and 12x. 10 plus 12 gives you 22. So it means that while factorizing, we understood that the second step, in the second step, we have to break the middle term bx into two parts and we have to show it as a sum of two parts. So I have to split bx into, let's say here, mx plus nx, and like here 22 is 10 plus 12, here b has to be m plus n. Understood? So we are now clear that in the second step of factorization, we have to show the middle term, we have to split the middle term into two parts and we have to make sure that b is equal to m plus n. The sum of the coefficient of these two terms, which we obtained by splitting the middle term, must be equal to the coefficient of the middle term of our quadratic polynomial. So b has to be equal to m plus n. This is the first fact, okay, or first process that we will do in the second step. So b is equal to m plus n. We have to use it. We have to follow b is equal to m plus n while performing the second step. Now what happened here? Observe, after breaking 22x into 10x and 12x, then in the immediate next step we can see it clearly that 2x has been taken common out of 8x square and 10x. It can be seen clearly, and from 12x and 15, 3 has been taken common. So 8x square and 10x, they have common factor as a 2x. They have 2x as their common factor. Maximum you can take 2x. So after taking 2x common, you are left with 4 in place of 8 and you are left with x in place of x square. From 10x when 2x was taken common, in place of 10 you are left with 5 and x is taken, so no x is left here. From 12x and 15, maximum common factor that we can take, highest common factor of 12x and 15 is 3. So 3 is taken common, 4x is left here and 5 is left here. That's it. After that, we could see that in the whole expression, we have two parts. Here, a monomial multiplied with a binomial, monomial multiplied with a binomial. And the binomial part is same. That looks like a surprise. So 4x plus 5 has been taken common here. After taking 4x plus 5 common, you are left with 2x plus 3. So 2x plus 3 is also inside bracket. Means 4x plus 5 multiplied with 2x plus 3. This ends your factorization process and you get the two linear polynomials as the factor of this quadratic polynomial. So here simple mathematics, simple process of solving was used where we took common, and surprisingly we found the same binomial in each part, and that binomial again in the next step was taken common here, and then 2x plus 3 was left. This is what happened here, right? So after following b is equal to m plus n, means after splitting the middle term in the second step, the things will be like this, right? Now one question arises. We have to write b as m plus n, like bx as mx plus nx. But have a look. 22 is no doubt 10 plus 12. We know it. Okay, 22 is 10 plus 12. But at the same time, don't you think 22 can be written as 16 plus 6? Say 22 can be written as 11 plus 11, or we can write it as 18 plus 4. Taking 10 plus 12 works here. Can we make this work by taking this pair or this pair or this pair? Will it work also when we take 16 and 6 for 22x, 11 and 11 in place of 22x, or 18x and 4x in place of 22x? Will it work? Let us see. For that, I will start with the quadratic polynomial again, 8x square plus 22x plus 15. Now here I am writing in place of 22x 16x plus 6x instead of 10x plus 12x. Instead of 10x plus 12x, I wrote 16x plus 6x. That also gives me 22x. Let's see whether it works or not. So now from these first two parts, let's take something common from 8x square and 16x. 8x is highest common factor from these two parts. After taking 8 common and after taking 1x, only x is left. Here in this part, 2 is left, x plus 2. From these two parts, what is common? 3 is common. So after taking 3 common, I will be left with 2x plus 5. Now that surprise or that miracle is not happening. Here you are left with 4x plus 5 as well as here 4x plus 5. But in this case, you see, in the first part and the second part, you don't have the same binomial. This is x plus 2, this is 2x plus 5. The miracle is not happening. Surprise is not happening. Why this happened? Actually, this happened because you took 16 and 6 in place of 22. If you take 11 and 11 or 18 and 4 or any other two numbers which gives you the sum 22, then this thing will not work. This thing will not work. You don't get a binomial as common factor, so you cannot take anything common out of these two expressions. So that's why out of these two parts you cannot take anything common. So that's why now factorization will not be possible. So by taking 16 and 6 or 11 and 11 or 18 and 4 or any two numbers which sum is 22, you will not be able to factorize. Okay, only by taking 10 and 12 you will be able to factorize this particular quadratic polynomial. All right. So what actually we have to also understand? We understood that b has to be represented as m and n, m plus n. So there is something else also that we have to understand to go for this step where the same binomial will be left. Fine. So for that, let's observe one thing. What happened here actually, you see, 2 was the common factor of 8 and 10. So that's why after taking 2 common, you were left with 4 and 5. Observe this. The highest common factor when taken out of 12x and 15 as a common, so you were left with 4 and 5. I mean, when you took 3 common out of 12 and 15, you are left with 4 and 5. Here also you are left with 4 and 5. Here also you are left with 4 and 5. It means what? It means that 8 and 10. I can show you 8 and 10 when divided by 2, you got 4 and 5. Similarly, when you divided 12 and 15 by 3, you got 4 and 5. It means that 8 by 10 is equal to 12 by 15 in terms of ratio. I can say you that, correct? So 8 by 10 will be no doubt 4 by 5, and 12 by 15 will be also 4 by 5, correct? I can write it properly like this: 8 by 10 equals to 12 by 15, because both will give you 4 by 5. From here you can understand, when you divide 8 and 10 by 2, you get 4 and 5. So 8 by 10 will be 4 by 5. When you divide 12 and 15 by 3, you will get 4 by 5. That means 8 by 10 will be equal to 12 by 15. So I wrote it. Now from this, I'll formulate. See, 8 is what? If you compare this step with this step, you can understand that A is 8. So in place of 8, I write A. Who is 10? The second coefficient of the second term, means M. M is 10. So in place of 10, I write M. Then 12 is the coefficient of the third term, which is N here, and the constant term 15, which is C. That means 8, 10, 12, 15. These four things have to be in proportion. 8 by 10 will be equal to 12 by 15. Two ratios of 8 to 10 and 12 to 15 are equal. So these two ratios are in proportion. In other words, 8, 10, 12, 15 has to be in proportion. 8, I can say, in other words, 8 is to 10 has to be in proportion with 12 to 15. In other words, you can understand from here like this: 8 is to 10 is equal to 12 is to 15, which means A by M is equal to N by C, which means cross multiply, and what you get, you see, A with C gets multiplied AC, M with N, Mn. This is the second fact. We had fact number 1 here, and this is fact number 2. So while doing factorization, we have to take care of these two facts. B has to be equal to M plus N, and product of this M and N has to be equal to A into C. A into C. What is A and C? A and C are the constant term and the coefficient of the first term, leading coefficient. Okay, so we have to take care of these two facts while factorizing. Then this miracle will happen. 4x plus 5 and 4x plus 5, as we got here, we got the same binomial in both these parts. We will always get the same binomial because of that particular thing. Because just we discussed that after taking 2 common here, we were left with the same number. After taking 3 common here, we were left with the same number. It means that this A, M, N and C has to be in proportion, and if they are, once they are in proportion, undoubtedly you will get the same numbers inside the bracket, same binomial in both these parts. So this is not a miracle or not a surprise. It is just a mathematical structure, correct? That's it. Now we will talk about these two facts. I'll clear the blackboard. Let us carry these two facts for our next parts. In this part, we understood that why we actually express or split bx as mx plus nx. From here we understood. When I wrote the steps of multiplication backwards, we understood that bx has to be split into 2 parts. Then we understood b cannot be split in any random way. I mean, b cannot be written as a sum of any two numbers. 22x cannot be written as sum of any two terms like 16x plus 6x or 11x plus 11x. It has to be written as 10x and 12x only. Because if we take any other thing, then the same binomial is not coming up. The miracle is not happening. So we had to follow this particular part. By understanding this all, we understood that by taking the common factor out of the two groups, we got the same binomial, which means that A, M, N and C has to be in proportion. So if A, M, N and C are in proportion, A is to M, proportional to N is to C, then we get A by M is equal to N by C, which means AC is equal to Mn. From this part we understood that product of constant term and the leading coefficient has to be equal to the product of m and n. Then only this thing will work, and you will get the same binomial as common factor to go for the last step, to reach at the last step of the factorization. That's it. So from here, let us carry forward these two facts. Now, if you are wondering that whether this thing works just with whatever we discussed now, it works for all the cases or not. Yes, it works for all the cases. I can explain you that algebraically also. For that, let me show you again. I'm taking two linear polynomials in algebraic form. For example, dx plus e is one of my linear polynomial and the other one is fx plus g. I'll multiply these two. Like in the previous case, I multiplied 2x plus 3 and 4x plus 5. Here, dx will get multiplied with fx plus g, plus e also will get multiplied with fx plus g. Now, by distributive property, dx into fx gives you df x square. Here, d, e, f, g are numbers. D, E, F, G are numbers. X is variable. Okay, so D is a number, F is a number. D and F are multiplied to give you df. It is any number. Now, x into x is x square. Similarly, d into g, dg, this is a number, into x is there. Now, e into f, ef, and x plus e into g, which is our constant term, it is a number. So, if you now take common from the second two terms, dgx and efx, x is common, and dg is left with ef plus eg. If I compare it, this is in now standard form of our quadratic polynomial. It is in the form of ax square plus bx plus c. All right. Here a represents df, b represents dg plus ef as a whole, and eg is represented by c. That's clear. Let me write the step of multiplication backwards. df x square plus x into dg plus ef plus eg. Then just the previous step was df x square plus dgx plus ef x plus eg. Now, what is the next step? You can see in the backward manner, this is our next step. What we have, dx into fx plus g plus e into fx plus g. Clear? Then final step, which is our product of, which gives the product of the two linear polynomials, or the last step of our factorization, dx plus e into fx plus g. So we arrived at the last step. This is factorization of this particular quadratic polynomial. That's it. Now, again, if we compare with our previous discussion, then let us check whether this particular thing, which is actually b, if you compare with the standard form, b represents dg plus ef. So, has it been split into two parts? Yes, dg is here and ef is here. dgx plus efx gives you this. Clear. So, b is equal to m plus n. Verified. Okay, this is verified. Now, second thing, let's see. We told that a and c, product of a and c has to be equal to product of m and n. Is it also working here? Yes, it is also working. Let me show you. To prove this, I am taking mn. I am starting with mn, the RHS part of this particular relation. M into n. M is dg and ef is n. dg into ef. If I write it, it is like d into g into e into f. Now, if I interchange between these all factors, d, let me write d with f, and let me write e with g. Okay, e with g I wrote d with f. I interchange the factors. You can see that what is df? Compare. A is df. A was df. Here B was dg plus ef. and C was EG. All right. So B was DG plus EF, and we saw that B is M plus N. Here M is equal to DG and N is equal to EF. Right. Now we are checking whether M into N gives you A into C or not. So M into N gives you A into C or not. Mn is equal to DG into EF. DG EF I wrote like this. Then I interchange between the factors, and you can see that DF is nothing but A and EG is nothing but C. C is EG, A is DF. So in place of DF I will write A, in place of EG I will write C there. A into C. Clear? So product of M and N is A into C. At the same time, I can show you DF is A, DG is M, EF is N, and EG is C. This is A, this is M, this is N, and this is C. A is to M is equal to N is to C. By that way, you can also check A is to M. A is to M means DF is to DG. DD gets cancelled, you get F is to G. Now when you check for N is to C, this gives you EF is to EG. This is EF is to EG. E gets cancelled, you are left with F is to G, which means that A is to M is equal to N is to C. A is to M is equal to N is to C. That means A by M is equal to N by C. That means A into C equals to M into N. This is how we can also verify. We verified in this part of the class today. We understood that yes, B is equal to M plus N and AC is equal to Mn has to be taken always while factorizing. Algebraically we checked it, we verified it, and we understood that yes, algebraically it is working and it has to work. Means in all the cases we will go for these two facts. We will apply these two facts while factorizing. That's it. Now students, we are with the fact that B has to be equal to M plus N in the standard form of quadratic polynomial. While we go to factorize, then Bx must be represented as Mx plus Nx. Means B has to be equal to M plus N and AC must be equal to Mn. Let me say this is first equation and let me say this is second. Now I will try to actually find out what can be the value of M and N in terms of A, B and C. Actual value of M and N. A, B, C are real numbers. So value of M and N in terms of A, B and C, what it can be, I will find out. So for that I will observe this is M plus N is B, this is Mn is equal to AC. So I want to find out what is M, what is N. I need M minus N. And yes, I can find out M minus N by the help of algebraic identities. Okay, we know that M minus N whole square equals to M plus N whole square minus 4Mn, isn't it? This is the standard identity. You have M minus N whole square is equal to M plus N whole square minus 4Mn. Now M plus N means B, so B square, M plus N square means B square, minus 4 into Mn. Mn is AC, so 4 into AC means I have B square minus 4AC. M minus N whole square is equal to B square minus 4AC. Now what I get? Only M minus N equals to what? I will have plus minus B square minus 4AC root, plus minus square root of B square minus 4AC. This is value of M minus N. That's clear. We got M minus N now. Let it be equation third. Now I will use equation 1 and 2 and I will add this 2. Okay. Adding I and triple I. So adding the two equations, I am taking RHS from this, M plus N, adding with LHS of this, there is no problem, equals LHS of this and RHS of this. B, in fact I can show you. This can be written as m plus n for your easy understanding. I can write b is equal to m plus n as m plus n is equal to b. Now you can understand quite clearly. Those who feel why I added LHS with RHS, for them I'm making it clear. B is equal to m plus n means it can be written as m plus n is equal to b. Now you can understand that LHS added to LHS. That's it. It is actually the same thing. So m plus n plus m minus n is equal to b means RHS plus RHS plus minus square root of b square minus 4ac. Now what I get? M plus n plus m minus n is equal to b plus minus b square minus 4ac. So plus n minus n cancelled. I am having 2m is equal to b plus minus b square minus 4ac. Now m equals to b plus minus b square minus 4ac by 2. 2 goes to the other side and divides the RHS. So we found value of m. M in terms of a, b and c. We got it. This is value of m. This is not quadratic formula, remember. This is value of m. Okay. In quadratic formula we will have minus b plus minus b square minus 4ac root by 2a. This is not quadratic formula. This is value of m. This is giving you value of m. Now using value of m, I can find out the value of n. See how. Putting m is equal to plus minus, sorry, b plus minus b square minus 4ac by 2a, sorry, by 2 in equation I. Equation I is m plus n is equal to b. That means n is equal to b minus m. That means n is equal to b minus b plus minus b square minus 4ac by 2. In place of m, I have applied the value of m. Now you take the LCM of these two expressions. 2 is the LCM. 2 into b will be 2b. Minus of b, minus b. Minus of plus minus will be minus into plus becomes minus, and minus into minus becomes plus. I can write minus plus root b square minus 4ac by 2. 2b minus b gives you b minus plus b square minus 4ac by 2. So this is value of n. Correct? We got value of m and n both. Now see clearly, when you take m as b plus root b square minus 4ac by 2, at that time n will be b minus root b square minus 4ac by 2. I have written here minus plus, here I have written plus minus. It means that when n is b minus b square minus 4ac root by 2, at that time m is b plus root b square minus 4ac by 2, and when n is b plus root b square minus 4ac by 2, at that time m is b minus root b square minus 4ac by 2. So whatever it is, one part means when we write b as m plus n, if m is b plus b square minus 4ac root by 2, then n is b minus root b square minus 4ac by 2, or vice versa. Okay. So for our next part, I will take, let m be b plus b square minus 4ac by 2 and n be b minus b square minus 4ac by 2. I will use this too. You can take m as b minus root b square minus 4ac by 2 and n as b plus root b square minus 4ac by 2. I have taken like this. So this we will now use for factorizing our standard form of quadratic polynomial. Okay, let's start. So here we go. I will write the standard form of quadratic polynomial. In fact, because we are going to find out the solution to our quadratic equation, so let me not just write quadratic polynomial, let me write quadratic equation. How? Put equal to just 0. This becomes quadratic equation, standard form of quadratic equation. Let us factorize and find zeros of this quadratic equation. In other words, we are going to derive quadratic formula. See, as we have discussed already in our today's class, that bx will be written as mx plus nx. So bx will be written as mx plus nx and then plus c is equal to 0. Now, in place of m and n, I can apply this. But before that, let me do something else. We know that AC is equal to mn. So c is equal to mn by a. Okay. To make my factorization simple, instead of applying m and n here, I went for this. This was a fact. We have two facts. B is equal to m plus n and AC is equal to mn. So from this fact, we can understand that C is mn by A. If I take that, it will be helpful for me to take common. You see, ax square plus mx plus nx. In place of C, I write mn by A equals 0. Now, from these two parts, what is common? From the first two parts, let's make the group of first two terms and the last two terms. From these two, we have common x. Ax is left plus m is left. Here I have nx plus mn by a. From these two parts, n is common. After taking n common, you will be having x plus m by a. But our requirement is ax plus m. I can get this by doing like this. You see, nx is there. I'll multiply a by a in this particular term. Multiplying a, dividing a. Multiplying by the same number and dividing by the same number brings no change in the term. So here already we have mn by a equals 0. Now I will take common from these two parts. I skipped taking common here to explain you this. Ax plus m plus, because I did like this, I will be now having the same binomial left here. You see, if I take n and this denominator a as a common, in this term what is left? X is left and a is left. So I am left with a and x, and here n by a is gone, m is left. So now you can see this part give you the same binomial. The same binomial taken common now, ax plus m, you are left with, after taking ax plus m common, you are left with x plus n by a equals 0. So we factorized ax square plus bx plus c. Now, we know that when two things are multiplied, the product is 0, suppose, then either both of them are 0, or first polynomial is 0, or the second one is 0. So, ax plus m is 0, or x plus n by a is 0. We have x plus n by a is 0. Now what we have? If I have ax, now ax is equal to minus m, and in this part x is equal to minus n by a, plus n by a goes to other side, becomes minus n by a. The next step is x is equal to, you will have minus m by a, and also x is equal to, we have minus n by a. That's it. Now putting the value of m in this step, you have m is equal to b plus root b square minus 4ac by 2. Let us apply that. So I will have minus here already is there. In place of m, I can write b plus b square minus 4ac by 2, and again I have by a. So in the numerator, in place of m, I have written the value of m, and in the second part, I'll put the value of n. I have minus already, so minus of value of n. N is b minus b square minus 4ac by 2, and I have a. Now in the next step, let me show you how it will be done. X is there, minus of b is minus b, plus, sorry, minus of plus is minus root b square minus 4ac by 2. This is my numerator. Denominator is a. I'll write it separately like this, into 1 by a. And the second part also, let me show you. x equals to, I have minus of b is minus b, minus of minus is plus, b square minus 4ac by 2. This is my numerator and a is in the denominator. I can write that as 1 by a. Now the next step gives you minus b square minus 4ac by 2 into a, 2a, and in this part minus b plus b square minus 4ac by 2 into a, 2a. Isn't it our quadratic formula? We have this from our quadratic formula. This is alpha, this is beta. Combining these two, we can say x equals to minus b. See, exactly these two parts are same except minus and plus. I can use them like this. X is equal to minus b plus minus b square minus 4ac by 2a. So this is our quadratic formula. We started with our standard form of quadratic equation. Then we wrote bx as mx plus nx. Then we wrote c as mn by a. From where we got that? From the relation. We know that m into n has to be a into c. So c is equal to mn by a. That's it. C kept here on left side, a goes to other side. So mn by a you have. So in place of c, I wrote mn by a. And nx is written like this, nx into a by a. Why I wrote a by a here? Dividing a with a doesn't bring any change in this term. But why I wrote this? I wrote this because I wanted to have the same binomial left in both these two parts. Here ax is left. If I don't include a here, I will be left with only x after taking n common. You can see n is only common in this step. But when I introduced a by a, now I will take n and this a, denominator a, from both these parts, n and a, n by a common. So what is left? X and a is left. And here only m is left. After taking n by a, you are left with a into x, ax and m. So after that your factorization got simple. You had the same binomial left in both these parts. The same binomial is taken common and you are left with x plus n by a now. Now it happened simply as we solve our equation. And then we inserted the value of m and n here and we finally got our quadratic formula. So using factorization method, we also found our quadratic formula. Hope you understood all these things what we discussed today. What is factorization, how it works, why it works in case of quadratic polynomial, and how we applied it to get the quadratic formula starting with our quadratic equation. We understood all this. Now in exercise 4.2 in your NCERT mathematics book, we shall talk about the questions where you are asked to solve the questions using factorization method. So whenever you are doing factorization, you understood that you are going to break the middle term into two parts, mx and nx, such that b has to be m plus n and product of a and c must be equal to product of m and n. Making those two things sure, you can proceed for factorization. And at the same time, let me tell you, when you are factorizing, when you are going to factorize your quadratic equation, you can use m is equal to this formula and n is equal to this formula to exactly know what will be taken in place of b. I mean the value of m and nx, n. These two particular part you can discover, you can find out by using this formula. To find out m, use this formula, m is equal to b plus b square minus 4ac root by 2, n is equal to b minus root b square minus 4ac by 2. Using these two formula, you can get the value of m and n, and always it will work. You will be able to factorize easily, and always the same binomial will be left in the two parts if you follow these two formula, if you use this two formula. Thank you very much. Hope you liked today's class. See you in the next class. We shall have exercise 4.2 where we shall use these things to factorize the quadratic equations, and there are some numerical questions also. We will go into that. Thank you for now. Take care. See you in the next class.